All right. This is going to be a basic hypothesis test. Um, the setup for this situation is that we have information about the average length of a gray squirrel being 21 inches. We have somebody who thinks that squirrels at the University of Findlay campus are longer, so he takes a sample of 40 campus squirrels and tests that against a level of significance of 0.05. So he takes a sample, he calculates the basic stats, and finds that the mean of the sample is 21.71, and the standard deviation of the sample is 1.82. So that's just a rundown on the problem. To write this down in the notation, the first thing to do is to determine the null and alternative hypotheses. The key here is that Alan thinks that squirrels at UF are longer than 21 inches, so my null hypothesis is that predetermined 21, and my alternative is that we think they're longer, so the mean is greater than 21. Also, we want to dig out all of the basic stuff from the problem. This 40 is the sample size. That's my n. My mean was the 21.71, and my standard deviation was at 1.82. Alright, so that's just writing down everything from the problem. The next thing to do is to calculate the t-value for the statistics that we have. So we're calculating the t-value for this particular sample. Our point estimate is x bar. That's our estimate of mu. That's our best guess for mu. Our t-value formula is this. That's our standard z-score formula. So I think I should know everything for that t-value. X bar minus mu. That mu is the null hypothesis. Remember that for these hypotheses tests, we're always assuming that the null hypothesis is true to start out. So we're assuming that the mean actually is 21. Then we divide by the standard deviation of that sample mean distribution, which is the standard deviation of my sample divided by square root of the sample size. So that's how I calculate my t-value. That's a calculator problem. I get about 2.467 for that. Alright, so that's the t-value for my sample. Now I want to compare that to alpha. So this is a t-value. This is how many standard deviations away from the mean we are. This alpha represents a probability. I need to convert one to the other to be able to compare the two. So right now, our alternative hypothesis is that we think the mean is bigger than 21, so we're on the right side of our distribution. Our alpha is 0.05, so we want this t-value to fall in that critical range so that we can reject the null hypothesis. Let me convert the alpha to a t-value first. So my alpha is 0.05. I want to figure out what t-value corresponds to that. To do that, I need to use the degrees of freedom. The degrees of freedom for our basic hypothesis test is the sample size minus 1. So in this case, our sample size is 40. Degrees of freedom are 39. This I look up on the chart and I get a t-value about 1.68. So my t for the alpha is 1.68. My t-value for my sample is 2.47. Based on that, my t-value for my sample fell in that critical region, and I can reject the null hypothesis. So 2.47 is farther away from the mean than 1.68. And I can reject the null hypothesis. The other method is to convert my t-value into a probability, and that's the p-value method. So if my t is 2.467, again, I can look at that chart and come up with some sort of estimate for my p-value. For this, I get a p-value of about 0.009. When I compare p-values to alpha, I want my p-value to be less, so again, I'm comparing this 0.009 to this original 0.05. Since my p-value is less, I reject the null hypothesis. Once you have this and this, this is the t-test on the calculator, and the calculator can handle all of that. When you do it on the calculator, the easiest thing to do is to use the p-value. It'll give you the p-value, and then you can immediately compare that to alpha and make sure it's less. So you always want your p-value to be less than alpha. That means that the sample you got is more unlikely than this threshold for being unusual. Alright, so that's our basic hypothesis test.